It's such a pleasure to welcome you all to Upper House tonight, whether you're with us in person or joining us online. I'm Dr. Dan Hummel, Upper House's Director of University Engagement. It's my pleasure to welcome you to the second annual Geneva Forum at Upper House. In partnership with Geneva Campus Church, the Geneva Forum is intended to elevate deep Christian thinking and the life of the mind. Our unique partnership brings to Madison leading Christian voices in conversation with the Reformed tradition, who will add to the thought life of the University of Wisconsin-Madison and the larger community. Last year, we welcomed our inaugural speaker, theologian Vincent Baycoat, who spoke about faithful politics in a divided world. This year, we're excited to welcome Dr. Deborah Haarsma, president of BioLogos, who will be speaking to us about God and the multiverse. Tonight's event at Upper House would not be possible without the support of Geneva Campus Church's congregation and leadership. From collaborating with Dr. Haarsma on events over the past 2 days at both Geneva Campus Church and Upper House, to shuttling Dr. Haarsma around town. This has truly been a partnership for which all of us on the Upper House staff are very grateful. Can we give a round of applause to Geneva Campus Church? And so, in that spirit, here to introduce Dr. Haarsma is the lead pastor of Geneva Campus Church and co-planner of the Geneva Forum, Reverend Jim Kirk.
Thanks so much, Dan. It's always such a pleasure to work with you and the rest of your team here at Upper House. We're really grateful for the partnership as well. As we've been preparing for this year's Geneva Forum, I've been thinking a lot about a book I read last summer. Perhaps some of you have read it as well. Every year at the University of Wisconsin, our chancellor sponsors a book program called the Go Big Read to engage the campus community in a shared reading experience. And this year's book was a powerful work of fiction called Transcendent Kingdom by Ghanaian American author Yaa Gyasi. And the story is about a PhD student named Gifty, who is in neuroscience at Stanford University, studying reward-seeking behavior in mice and the neural circuits of depression and addiction. And it's a beautifully told story, intertwining themes of the American immigrant experience, racism, suffering, science, and faith. As a pastor, I was especially struck by the way in which the book portrays the relationship between science and faith. Throughout the story, Gifty struggles to connect her childhood Christian faith with her scientific training. She finds a way forward in the end, but she often feels that she must choose between what she is discovering in the lab and what she reads in the Bible. Well, at Geneva Campus Church, we believe that our culture too often presents us with a false dichotomy like this between science and faith. And we're sponsoring our lecture tonight to offer an alternative, a vision of integration between faith and science. Our speaker is Dr. Deborah Haarsma, who's president of the BioLogos Foundation. BioLogos was founded by Francis Collins, who was, until recently, the director of the National Institutes of Health. I believe he's now a special advisor to the president. And the vision of BioLogos is that science and faith would work hand in hand, and its values are Christ-centered Christian faith, rigorous science, and gracious dialogue between different points of view. Dr. Haarsma did her undergraduate work in physics and music at Bethel University in the Twin Cities. She completed her PhD in astrophysics at MIT. As an astronomer, Deb studied large galaxies, galactic clusters, the curvature of space, and the expansion of the universe using telescopes around the world and in orbit. Prior to joining BioLogos, she served as professor and chair of the Department of Physics and Astronomy at Calvin University. And I'm so grateful for the opportunity for us to hear from Dr. Haarsma tonight on this theme of God and the multiverse. We need more people like her who are able to offer a bridge for us all between the world of science and the world of faith in order to show that they are not in conflict. Throughout Yaa Gyasi's Transcendent Kingdom, the reader overhears the prayers of the neuroscience PhD student Gifty, written over many years in her journals. In one of the earliest prayers, as a child, she writes, "Dear God, I've been wondering where you are. I mean, I know you're here with me, but where are you exactly? In space? I don't think I want to be an astronaut, but I would go to space if you were there." I'm not sure exactly what we're going to discover as we explore the multiverse tonight, but Dr. Haarsma, thank you for taking us to space and inviting us to see God in and through the cosmos tonight. Welcome.
Well, good evening, everyone. It is such a delight to be here. I've had a wonderful time so far in Madison, so big thanks to Dan and everyone at Upper House and to Jim and everyone at Geneva Church. I've had great conversations with students, with profs, with community leaders. It's been wonderful. And it's so good to have an in-person audience here and to have our online audience. So thank you all for taking time this evening. So we are here to talk about God and the multiverse. Just, nothing big, right? These have become, the multiverse is hip now. My goodness, it's on the big screen. So we have movies with many different Spider-Men from different universes. We have Loki and different versions of himself showing up. Science fiction is wonderful because it raises lots of interesting ethical questions. I really enjoy it because you get to explore different universes and see how they build different worlds. You get to see how they encounter different ethical questions. Often there are people who are trying very hard to do the right thing in a difficult situation. In here you get questions like, so am I in the right universe? Should I try and shift to a different universe? Is it ethical to fight for my version of the universe if it harms another version of the universe? Will I be an alligator someday in some other universe? Do you see the alligator? There it is. So here we have 3 different versions of Loki as a child, 2 different, we have a white man, black man, and an alligator. Okay, so people are really wondering these things. I first encountered a lot of this as a fan of The Next Generation back in the 80s. I don't know if anybody else remembers this episode, but here we have many versions of the USS Enterprise coming from different universes, all converging around some, techno-babble something in space. And there was even questions there, though, like one of them was saying, please, please don't send me back to my version of the universe. It's really awful there. Let me stay in yours, and kinds of questions like that. And of course, it goes further back than that in literature. We have the original series. You know which one's the evil one because he has the goatee. Okay, very important. I mean, I think that alone, right there, started a whole meme of goatees being the symbol for the evil twin. And people just love these things with alternate timelines. Can you go and be part of the other timeline? Well, the question is, how much of that is fact and how much is fiction? You know some of it's fiction, right? But which parts? And I'm here as an astronomer to help you sort that out. Some people are starting to think some of this is really real. Apparently there is a trend on TikTok, not that I'm on TikTok, okay, but somebody else wrote an article with a link to TikTok, and somebody there posting videos saying, oh, I shifted timelines last week. I have different memories than my friends of what happened, and so I shifted into a different timeline. You should try it. My life is so much better now. And even advice, if you want to shift timelines, go and take a cold shower and then shift it to the hot temperature, and then you'll shift to a different timeline and think really hard about where you want it, like, oh my. So no, that part doesn't work. So spoiler alert, we're going to find out that you cannot jump between timelines, sorry. But you might have a double out there somewhere. So that's a little spoiler. But to get there, we're going to have to give you some more scientific background, and especially if we're going to talk about how God fits in the picture, we'll need to lay some groundwork for that too. So, I am an astronomer. Here I am at the Very Large Array Radio Telescope in New Mexico. I've used a lot of different telescopes, but this is the one I've used the most. And this is, it's a really cool instrument. It has these very large antennas. Each of those is 25 meters across, like a quarter of a football field, and they're carried up and down these railroad tracks, so you can move them around and have them be more spread out or closer together. And I got to use this instrument to study some amazing things. Galaxies, very distant galaxies, galaxies that are much larger than our Milky Way galaxy, galaxy clusters, and the curvature of space. So I didn't take this image. Okay, this is really cool, though this is one of my favorite images of a galaxy cluster. And what you're seeing here, and anybody who's done a Zoom call with me in the last couple of years knows that I have this a big poster right behind me when I'm doing Zoom. And in this image, you see a lot of yellow blobs, okay? Each of those blobs is not a star. It is an entire galaxy containing billions and actually trillions of stars. And our own Milky Way galaxy would be quite small compared to these. The biggest yellow blobs you see there are about 1,000 times larger than the Milky Way. The Milky Way is our galaxy, which has hundreds of billions of stars in it. You can also see these blue arcs. Do you see the kind of the arcs going sort of around these little fragments of curves? That is an optical illusion created by curved space. There is so much mass concentrated here, much of it in dark matter. We don't even know what the dark matter is, but we can see its impact on space. It is causing the light to bend around this galaxy and to distort things behind it so you get this crazy house mirror kind of effect. And it's just amazing to study things like this. And this is just in our universe. So in all of our desire to learn about other universes, keep in mind how big and amazing our universe is. So I love studying things like this, and there is that moment, you go through a lot of hard work, you write your observing proposal, you get your data at the telescope, you process it and remove artifacts, and then an image comes up on screen and you go, is that it? Is that it? Oh, I think I see it. And you see a little artifact, and then you're like, okay, but is that really the thing I'm looking for? And eventually go, okay, yeah, it is. I have seen something new in the universe that nobody has seen before. And it's a pretty special moment. But I think everyone has some of those moments of just wonder at the universe. So if you're outside at night, okay, a lot of times it's cloudy, but get in the habit of looking up, see what you can see. You're here in Madison, you're not too far from a lot of dark sky sight in the country. Just drive a little ways out on a cold, dark night, and you'll be able to see the stars and the Milky Way and the wonder of God's creation. I think everybody has some of that sense of wonder, you know, that feeling where you look up and kind of your eyes get big and your jaw drops and your shoulders relax and you go, wow, that's amazing. There's research done that moment of awe actually changes things it reduces your stress, it lowers your blood pressure. God wants us to experience the amazingness of his creation. Because for us, as Christians, we know, and if you're not here as a Christian tonight, I'm sorry if I slip into that language, view this as a chance to see what Christians think. For me, I see that the heavens are declaring the glory of God. It's not just a generic sense of awe, but it's pointing to this person behind the universe, that there is a creator. The universe didn't just arise on its own or from some impersonal force, but from a person. And that person, as Christians, we can actually know. That person is Jesus Christ. In John 1, in Colossians 1, these Bible passages clearly teach that Jesus Christ was part of creating this amazing universe. Through him, all things were made. So the very one who created these amazing wonders I get to study in the universe is also the one who knows me, who loves me, who forgives my sins. And that is truly amazing. So for me, a scientific explanation does not replace God. It just reveals more of God's handiwork. I get to discover new things that God has made or figure out more about how God went about making them. For me, these two things go together. I've been a Christian all my life. I've been a scientist all my professional life, and I have not found deep conflict between these things. Now, there are tension points, but at a fundamental level, for me, they go together. So we're encountering God's world and God's word. Now, there are a lot of places where these intersect, and I would be happy to talk about those in the question time. So things people often wonder about, well, how do I fit the Bible with the science stuff? We're talking about a universe billions of years old. The Bible says 6 days. How do you put that together? I believe the Bible is God's authoritative word to us, and I believe the scientific evidence. You can ask more about that if you want. Or we can talk about any other place where you see a tension point, evolution, aliens, whatever. For now, I do want to focus on the multiverse. You can also, though, go to the BioLogos website, biologos.org, and learn more. We address all of those topics and many more on our website. You can read articles, you can watch videos, you can chat with people on our forum. Great place to come and share your ideas and questions. People would love to engage you. We have a podcast you can listen to. We've got a table back there with some information at it and a sign-up sheet if you want to start getting our emails, or you can just follow us on social media. And everything we do, whichever topic we're talking about, we bring together Christ-centered faith with rigorous science. So often in our culture, and even more so in the last few years, these things seem to end up on opposite sides of a big polarized divide. And it's as if you accept science, you couldn't possibly be a person of faith. Or if you're a Christian, you couldn't possibly accept science. Well, the extreme voices are saying that. There's a lot of people in the middle who are open to both. But even so, a lot of questions about how they go together. And at BioLogos, we want to show people these things can go together. And we aim to do so in a spirit of gracious dialogue, which is also really hard to find in today's culture. So come and check us out. You can also, I encourage you to check out our conference. Our Faith and Science Conference is coming up March 25 to 26. And you can get a virtual pass and engage all these amazing speakers. We have David Brooks from the New York Times. We have Francis Collins, our founder, former director of NIH. We have Mako Fujimura, an artist. We have Alistair McGrath, an amazing theologian. And I can assure you these other speakers whose names you might not have heard of are also excellent and have wonderful things to share. So I encourage you to check out our conference. And if you're not available to watch it all day on March 25 and 26, your virtual pass will let you watch those lectures for 3 months following. So it's a great bargain. Okay, so a little more background on the universe, our universe, and because that's something we can actually observe. So we can't observe other universes. That's the whole point. In another universe, it is completely separate from us. But we can observe things about our universe that give us some possible insights into what's going on. So our universe contains trillions of galaxies, each of those galaxies with trillions of stars. Here's just a sample of a bunch of different images. And in our universe, space is expanding. And these galaxies are all moving apart, and the separation between them and the speed at which they move are related. And it looks a little something like this. A little jerky here on the animation, but the galaxies are all spreading apart. This is a little bit like raisin bread. I don't know if you're a bread baker, a lot of people took up bread baking during the pandemic. If you have a loaf of bread, and if you've tried to make raisin bread, you got to get those raisins in there. It's kind of hard. But once the raisins are in there and then the loaf of bread rises, it carries the raisins along with it. Okay, so in this analogy, the raisins are like the galaxies. The bread is the fabric of space-time. So space-time is expanding and carrying the galaxies along. So the universe is expanding. And it turns out it is accelerating in its expansion. It's getting faster and faster as time goes by. So I'll do it with my hands here. Hopefully you can see. So, steady expansion would look like that. But what we've actually found is that it starts off fast, kind of slows down, and then speeds up. Starts off kind of fast, slows down, and then speeds up. So it's currently in the speeding up phase, and it's accelerating in its expansion. Kind of freaky, but that is what we are finding. This discovery was made in the late 90s and won the Nobel Prize in 2001. Adam Rees there, back in the 90s, he and I were working on the same project of studying galaxy clusters, and then he went off and did this one, and I went and did something else. I was that close. That close. Oh. Okay, so Nobel dreams are dashed, but it's really cool science. The universe is accelerating in its expansion. So now let's pretend we're going to rewind the universe in our minds. We're going to hit the rewind button, and well, that would mean that the galaxies used to be closer together, and indeed they were. And if you keep rewinding, the galaxies in the early universe, well, all that matter would have been packed together, very dense and very hot. And that is the Big Bang model for the universe. The Big Bang is a scientific term that we use to describe this, but it's referring to this hot, dense state in the early universe and how things expanded and cooled after that. And for a while, it was mostly a thought experiment, like it's expanding now. If we rewind, then it would be like this, right? But do we have any evidence that actually did that? And it turns out that we do. In 1965, Penzias and Wilson discovered heat radiation from the early universe using this ungainly-looking telescope. This is a radio telescope in New Jersey, and they built it to detect just the faintest radio waves possible from space. They weren't even looking for anything related to cosmology or the beginning of the universe, but they were trying to find this. And they detected a faint hiss in the background, like it was, like there's something in our instruments. We're trying to get this most sensitive thing, and we keep picking up this noise. What is that? And they thought maybe it's the pigeons that were roosting in the antenna. So they scooped out all the pigeons and the debris, and they drove the pigeons away and let them go. Turns out they were homing pigeons, and the pigeons came back. Okay, so they finally get rid of the pigeons, couldn't get rid of the hiss of this radio noise. It was coming from all over the sky. And they got connected with the group down the road at Princeton University, where you had the cosmologists who didn't know anything about these instruments, but they knew all the theory of this, and they had just worked out, if the universe was hot at the beginning, all of that heat would have cooled off now and become a hiss at, microwave radio wavelengths. And they talked to each other and realized they had discovered this noise from the universe, the cosmic microwave background. So this is a current map, near current map of the afterglow of the Big Bang. And it's kind of a weird picture of the universe. Okay, it looks like two marbles there, right? So what you have to imagine is you're on the inside of the marble looking out, and that's what it would be if you're looking at the two halves of the sky. And you don't see green and blue because this is radio emission. It's not stuff that your eyes can see. It's invisible to your eyes, but these instruments can detect it, and the colors here represent regions where it's slightly hotter and slightly cooler. But it is actually a portrait of the entire universe that we can see all in this image here, which is pretty neat. So some years ago, my husband, did I mention my husband's also a physicist? For Valentine's Day, I got these earrings, which are the same picture. He gave me the universe for Valentine's. So that was pretty nice. Geek love. Oh, let's see if I can get it back in. Okay, so let's see here. So I mentioned the Big Bang, and to an astronomer, when they say that term, they are referring to a scientific model, like photosynthesis or gravity. It's a model that makes predictions, it can be tested, but also it has become to be used as have these atheistic overtones, that the Big Bang is somehow a replacement for God, an alternative to God. So Stephen Hawking says, a combination of quantum theory and theory of relativity would better explain our existence than divine intervention. Two separate explanations. But does that have to be the case? For me, the Big Bang is describing God's creative work, just as photosynthesis is a model that describes how God is has created trees so that they can process sunlight and get food from it. In the same way, the Big Bang is our description of how God went about saying, let there be light, and there was light, and there was an expanding universe, and there was eventually all the stars and galaxies. So a scientific explanation does not replace God. Okay, so one more piece before we get to the multiverse, and that piece is about fine-tuning. And it'll take me a little bit to get there. So we're going to do a little thought experiment here. What would our universe have to be like in order for simple life to exist? So we're not talking about fancy complex life like our brains or alligators. Let's just go with bacteria, some single-celled organism. What has to be true about the universe for there to be simple life? And is our universe special in some way in being able to provide that? If our universe were different, would this life be here? That's going to be the question. Well, one thing that life needs, even simple life, is a stable energy source. It needs stars. It needs a star that can just give out a nice steady radiation, heat, light for a long period of time. So we need stars. Simple life also needs a variety of atoms. Now, in the beginning of the universe, there was a lot of hydrogen and helium produced, little trace elements of other things, but not the whole array of elements that you really need for life, carbon, nitrogen, oxygen, and other elements. Those are all formed in stars. So we need stars to get a variety of elements. So we need nice, long-lived stars. Well, for stars to form and survive, we need certain things to be true about different laws of physics. So this is a little diagram here showing the formation of a star. It starts in the upper left there with a nebula, this amorphous cloud of gas and dust. And we see a lot of nebulae when we look out at our galaxy. And in many of them, we see regions where there's material that's collapsing down. So there's a concentration of material, and then that gravity pulls more material in, and it collapses down. Often it's slowly rotating to start, but as it collapses down, it speeds up. We just had the Olympics, so if you're watching, you saw the ice skaters as they bring their arms in. As things get tighter into the axis, they spin faster. That happens here too. And you get things collapsing down typically into a disk of material with then a concentration at the center. And at the center, it gets dense and packed enough that fusion turns on. So now we have hydrogen fusing into helium, eventually helium will fuse into carbon, and so forth. And so once the fusion turns on, then we say a star is born. But there's still this disk of material going around the star, and then the material in that disk coalesces into planets, and that's where the planets come from. So planets form around their host stars. It's possible that planets are captured later in the life of the system, but it looks like most times planets are formed around their host star. So if we're going to get a variety of atoms and a stable energy source, we need long-lived stars that can produce these elements and make planets places for life to live. Okay, long-lived stars require yet something else. They require the strength of gravity to be fine-tuned. So there's an equation for gravity. But basically, if the strength of gravity is large, then that cloud that's collapsing down will collapse down fast, and it will draw a lot of matter in. And yeah, you'll get fusion to turn on, but it's going to turn on fast, and it's going to burn through it. It's going to be a flash in the pan kind of thing. It'll be a star, but for a very short period of time. So that doesn't quite do what we need. We need stable, long-lived stars. So we can't have the strength of gravity being too high. But if the strength of gravity is too small, well, then that cloud doesn't collapse at all. The gas pressure would resist it. Maybe it kind of tries to collapse, but fusion never really turns on. And then you don't get a star at all. You need the strength of gravity to be just right, not too intense and not too weak. And if the strength of gravity is just right, then you get the kind of stars you need to have even just bacterial life. So we call this fine-tuning. We don't have analog radio dials anymore. But back in the day, you had to spin that dial just right and just tune it in just right to get the right spot, and then you could hear the radio station. And that's what is referred to here with fine-tuning. And it turns out for the strength of gravity and some other physical parameters, they have to be just right. And it turns out in our universe, they are just right for life. Obviously, because we're here. Okay, but it's made a good and fitting home for us. But the thing is, we can imagine lots of other universes where things were a little different, just like the thought experiment I played out. What if gravity is too much or too little? What if these other parameters are different? And then we couldn't have life. So the universe seems to be fine-tuned, finely crafted for life. And that resonates with a lot of Christian thinking, God designing the universe, God creating it with intention. But this isn't a Christian idea as far as where it arose. It's not exclusively Christian. Stephen Weinberg, Fred Hoyle are major leaders in physics and astronomy, and they say life as we know it would be impossible if any one of several physical quantities had slightly different values. And Fred Hoyle says a super intellect has monkeyed with physics. And he was an atheist. And he's like, oh, something's going on here. Richard Dawkins, fine-tuning is something that gives him pause. Now, this is a lot of Christians find a lot of assurance in these fine-tuning arguments. This is evidence for God's design and God's intent. But then we have the multiverse. And a lot of the multiverse theories seem to come up with an answer that says, well, our universe isn't so special after all, it's just one of many. So that brings us to the multiverse. So several caveats and framing remarks here. I've put up here 4 models, sort of
multiverses. There's like 9 or 10 out there. Figured that'd be too much, so we got 4. These are 2 books that are pretty good. Brian Greene and Max Tegmark. They are not Christians, but they mostly stick to the science. There's some of their worldview is evident, but you can learn a lot about the science from their books. The thing is, there's not just one multiverse theory. So anything we do talking about the multiverse, you have to be like, which one are you talking about? And of course, all that gets glossed over when we get to science fiction. They just kind of pick stuff from different ones. So there's multiple models. The first 2 here really have something to say about that fine-tuning. So I'm going to address those first. And then the second 2 on this list are where we get more into these like multiple timelines and duplicates and stuff. So we'll get to that. Now, each of these, there's some Christians who say, well, those atheists have just come up with these multiverse models to explain away God. They don't like the fine-tuning thing. They want to come up with some alternative, and so they've just invented these ideas. And that's not actually the case. So each of these, the fourth one's kind of self-evident, but the first 3 all arise out of trying to solve standing problems in physics. And you work through the physics, and you're trying to work out the answer, and then, oh, look, it also makes multiple universes. Didn't see that coming. So it wasn't like they were like, let's make a theory of multiple universes. They were trying to solve another problem. So we need to deal with it on those terms. And then a last caution, I think this is the last one. There's a lot of debate in the scientific community about whether this is even science. Okay, so I'm going to try and talk to you in very scientific terms, but is this even science? So here we have 2 leaders in the field, George Ellis, saying, the multiverse proponents are proposing weakening the nature of scientific proof. Like, them's fighting words. Like, okay, you guys aren't even doing science. And there's a case to be made there, because a multiverse, we're talking about other universes. By definition, you can't get to the other universe. You can't test it. You can't measure it. Is this even science if you can't test it? But then Max Tegmark says, well, does every prediction of a physical theory need to be testable in order to confirm the theory? And I'll get to a little more of what he means later, but there are some theories where we can test them in our universe, and they also predict a multiverse, so, what else are you going to do? So this is a very active debate among scientists. So, I'll quickly describe string theory. You can't quickly describe string theory. That's impossible, but I have to have it on the list. String theory, the motivation here is to understand how quantum mechanics and the general theory of relativity, which describes gravity, how these 2 things can fit together. And it is mathematically robust. There's a lot of meat to this theory, and it ends up proposing 11-dimensional space, which even if I had an hour would be too hard to explain, but anyway. This is a picture that is your standard 2-dimensional shot that is meant to portray this 11-dimensional space. The multiverse comes in where that shape, there's 10 to the 500 variations on that shape of how these different dimensions fit together. And then those can be expressed. So now we're talking about maybe there's 10 to the 500 different kinds of, that's 10 with 500 zeros behind it. Maybe there's that many different universes. Maybe the universes, they're sort of on these membranes and they can kind of collide together, and that's a big bang that spawns a universe. That's roughly how this one goes. As far as the implications for God and humanity, they're pretty similar to some of the other ones. So we'll just set this one aside. So, okay, if that didn't make any sense, we'll go on to the next one. The next one is called inflation theory. We have inflation again in our culture. There's 20% price increase over last year. We just bought a car, and wow, it's expensive. So yeah, inflation, that's not what we're talking about here. It's not about economic inflation. It's not about supply chain issues. It's about the universe. So this diagram here, you've already seen pictures like that last one where it says 13.7 billion years. That's referring to where our universe is now. And the one previous to that with the green and blue speckles, I told you that was the heat radiation from the early universe. And that is indeed from about 380,000 years after the beginning. Inflation, and the universe expands between that 380,000 years and 13.7. Each of those little green and blue blobs expand out to the size of galaxies and other structures. But there's something going on here between the tiny fraction of a second, or around there, and the word inflation is there. And what happens is an incredibly fast expansion of the universe in an incredibly short amount of time. So the numbers are expands by a factor of 10 to the 26 and about 10 to the minus 33 seconds. Okay, so the people in the audience who know about scientific notation are like, whoa, and everybody else is like, huh? Totally fine. It's a mind-blowing amount of expansion in a very short time, and it's not something that people just say, oh, let's just try this. You're kind of forced into this. This is something that's used to explain certain features of our universe, and it explains them very well. I'm going to show a graph here. You don't even need to know what the axes are. I won't take time to explain that, but do you see the little dots? That's the data, and you see the green line? That's the theory. And this inflationary theory explains exactly where those data points are extremely well. The error bars, the data points are as big as their error bars, and this theory matches it incredibly well. So, even though you don't know what that is, what I'm trying to convey is this inflationary model, bizarre as it is, actually explains real stuff in our universe extremely well. And this model predicts a multiverse. Okay, so now we're talking about a multiverse. And the way it happens is it makes many universes, each with different parameters. So they're kind of bubbles. So I found an image of bubbles here for you, and each of these bubbles would be a separate universe. There's no way to get from one bubble to the next. There's no going and seeing what's going on in the other universe. Moreover, they have different physical properties, so they might have different strengths of the law of gravity. You might go to one of those other bubbles and there's not even any stars there. They might have a different expansion rate of the universe, might have different physical properties. But the inflation model predicts that there's going to be a lot of them, and that's because the metaphor, it's a phase transition. It's a little bit like a pot of boiling water. You get the water up to a temperature and it starts to boil, and you don't just get one bubble, you get a lot of them. And there's a phase transition going on in this inflationary model that then produces a lot of universes. Okay, this explains some fine-tuning. So this problem, because we're just in one of those universes, and we're in one that is really well suited for life. But all these other ones, the physical laws are a little different, gravity's a little different, or whatever. It's like going into a shoe store. You know, you go shopping for shoes, and if you walk into a shoe store and supply chain issues, whatever, they only have one pair of shoes left, and you try it on, and it fits you, you're like, whoa, that's really what an amazing coincidence. They must have known I was coming. There must have been some design and plan here. The only pair of shoes left fits me. Whereas if you go into a shoe store and all the shelves are full and there's hundreds of kinds of shoes and you find one that fits you, you're like, yeah, of course. I mean, there's so many different kinds here. At least one of them was bound to fit me. This is the difference. If you have just one universe, it's amazing that life can survive here. If you have a gazillion universes, it's not so surprising that at least one of them would allow life. So, does the inflationary multiverse explain away fine-tuning? Not entirely, because this mother universe, this thing from which all these universes spawn, still needs to be fine-tuned. And it may still require a beginning. There's a theorem from Bordegun and Vilenkin about that. And you still have other apologetic answers related to the universe. Why is there something rather than nothing? If we're talking about, do we need God, do we need a designer? The inflationary model doesn't just make all of that go away, because we're still talking about some fine-tuning, and we're still talking about how did this all come to be here. Math still describes the universe, which to me as a physicist is the most amazing thing, that the calculations you can do actually fit physical reality. So a scientific explanation does not replace God. If there's a multiverse of the inflationary variety, and our bubble here is the one that fits life, I don't see this as a problem for Christianity. I can see this as a universe that God designed. Okay. But you came here, probably, to hear about science fiction. Okay, so we'll back out and we'll talk about science fiction. So there's Dr. Strange. Oh, I need to get some water before we talk more. So apparently in the upcoming movie, he's going to be doing even more to manipulate different aspects of the multiverse. And I already showed this picture from the Loki series of these different timelines and the people meeting up and all this stuff. So what's going on with this? So there is something behind this, and this brings us to the third model of the multiverse, called Mending Worlds Quantum Mechanics. And it's related to Schrodinger's cat. You might have heard of Schrodinger's cat. Poor cat. Schrodinger did this thought experiment and said, let's say you put a cat in a box, and he closed the box, but also in the box you have put some poison. That's a little orange thing there. It's got a skull on it. And you've put a little radioactive thing. Radioactive because that's a quantum mechanical process. When does a radioactive decay actually happen? And this is set up so that when this radioactive decay happens, that triggers the poison to be released and the cat dies. And with the box closed, you don't know when that radioactive decay is going to happen. Has it happened, not happened, not happened? And in physics, that's a superposition of two states. It's both happened and not happened at the same time. Only that means the cat is both dead and alive at the same time. Really strange. But the way it relates to this many worlds quantum multiverse says that as soon as that quantum event happens, a separate universe spins off, so that you now have two universes, one where the cat's alive and one where it's dead. Not a superposition of two states and some fuzziness, but two literal universes, one where it happened and one where it didn't. And then the next quantum mechanic event that comes along also splits things into two universes, and then again and again. Every quantum mechanical event actually splits the universe, creates duplicates. So we can do it here right now. So in a moment, I'm going to ask you to raise either your right hand or your left hand. And you're going to make a choice. You're going to pick which hand you want to raise. Okay, everybody got in mind which one you want to raise? Okay, raise your hand, right hand or left hand. All right, great. We just created about 2 to the 100 new universes because you made a choice. And in one universe, you raised your right hand, in the other universe, you raised your left hand, because you all had a moment of decision there, right? And both choices happened in this model, both choices happened, and each one created a universe. This makes a big assumption that there's a quantum mechanical thing going on in your brain when you make decisions. That's not a given, so that's a big assumption here. And I personally find this really extreme. Other people who've delved into it think, no, this is the best way of understanding quantum mechanics. But like really every single decision, every single physics event leads to a new universe. And so you get this constant splitting happening all the time. And so it's making duplicates of you, an exact duplicate of who you are right now, except in that duplicate they made the other choice of the other hand. And then that universe just carries on and goes on. They're going on living their lives. We're going on living our lives. It's a little wacky. But it is a multiverse. And Sean Carroll is a proponent of this. And he was the science advisor to the Marvel Cinematic Universe. So the Marvel movies, with their splitting timelines, are most closely related here to Sean Carroll's thought on this. So multiple timelines, if this is the right model of the multiverse, if this is the right interpretation of quantum mechanics, and if your decision-making process is actually quantum mechanical, then multiple timelines are real. Sure, great, got multiple timelines. The thing is, there's no way in this model that these timelines are interacting with each other. So if you wanted to go and meet the alligator version of yourself, sorry, you can't do that. Just doesn't happen. It happens in fiction, just not anywhere in this model. Pretty strange. Okay, I need to keep moving along here. I'll say more about free will in a second. So the last model I have of the multiverse isn't actually a multiverse. It's just our universe. And I bring this up because some of the questions we're talking about are raised just in our universe. It's nothing like talking about the multiverse to make our universe seem homey and approachable. Our universe is still really big, and we're not talking here now about changing the laws of physics, of having slightly different values of gravity. Our universe just has the laws of physics that it has. But we are talking about how big it is. So we have this region that we call the observable universe. There's been time since the beginning for light to travel across this region of space so we can see what's going on. But in every cosmology textbook I've ever seen, like on page 1, it says we are going to assume that the universe is uniform and isotropic, which basically means that the universe is infinite in extent, or at least extremely, extremely much larger than the part that we can observe. Okay, so if the universe is infinite, the thing about infinity is that it's really big, and you think about how really, really big it is, and then it's way bigger than that yet. It's just hard to get your head around infinity. But what happens is the universe is so big that out there is a planet that there's so many planets in this infinitely large universe. Some of them are going to look a lot like Earth. And some of those look very much like Earth. And since it's infinite, wow, there's lots and lots of planets. There's bound to be one that's really close to Earth. And in fact, there's an infinite number of ones really close to Earth. That means that there's one where there are people sitting in a lecture hall kind of like this, only I'm wearing like a red top instead of a blue one. You know, like everything's just the same but a little different. And so that means there might be a double of me out there somewhere. Okay, but how far away is that? Way beyond our observable universe, like trillions of times further away than things in our universe. There is no way you could ever encounter your double. Somebody calculated how far out this is. It's for those of you tracking all the scientific notation, I think this was 10 to the 200 meters or something away. It's just like, no, it was 10 to the 26. That was it. It just unimaginably far away is where your double is. So you might have a double out there, and if it's truly infinite, you would, but it's so far away you would never encounter it. So maybe there are multiple Spider-Men. Fine. We just can't connect with them. What does that mean for us? Does that bother you, that you might have a double out there? I don't know if it bothers me or not. Sean Carroll says he has no problem with it. He's happy to have doubles. Some people, that bothers them a lot. And it's kind of just like this gut feel of philosophy and theology. And at some point you need to sort of ground that in rationality. Like, well, okay, well, what would be the problem? Some people say, well, would my choices matter if that was out there? Would having doubles or copies out there mean that we don't have free will? Well, back in that many worlds model, there is something there about not having free will, because every choice gets made. You might have chosen one, but you've got a duplicate who chose the other, and so every choice has to be made in the many worlds quantum mechanics. In this one, that's not the case. A copy out there that's similar to me would probably make similar choices. Maybe not something about as arbitrary as left or right, but on anything substantial, they would probably pick the same thing. So we each are freely choosing, but we're choosing because we're similar. So I think free will seems to me that it still would exist, and it really doesn't impinge on our choices if there's a copy out there somewhere making their choices. What about value? Do we have meaning and purpose? Sometimes people go right there and like, okay, if there's duplicates out there, then do I have any meaning or significance? I've got a copy. Well, parents of identical twins see each of them as individuals. They have the exact same genetics, almost, and they are valued as individuals and make their own choices. So having a duplicate out there with similar genetics doesn't really impinge on you or on your personhood. Maybe they don't just have similar genetics, but similar, culture and values, but they're still a separate individual. Their brain is existing in a separate space. They have the free will to make their own choices. They won't be exactly your choices. So I think that we can still have value even if there are copies of us out there. So whether it's a universe or a multiverse, whether there's multiple timelines or not, whether there are copies of me out there or not, I still come back to the core of my faith. And this is exactly where faith should matter, is how we make our larger understanding of these scientific ideas. And for me, I believe God is the creator. Whether it's just this universe or all of this multiverse, I believe God is the creator. And I believe humans have purpose. My purpose isn't because of necessarily how unique I am, but it's because God created me with intention. God intended to create me, and God sees value in me. That's where my value and meaning comes from. God loves me for some reason, even though I sin and rebelled against God. God loves me and values me and wants a relationship with me. I mean, that's a huge source of meaning and purpose for each of us as humans, is our Creator has a desire to know us. My choices matter to God. Those are real choices. And God gives us a calling. God has, said, here's your purpose. Go forth, love your neighbor, love me, love your neighbor, serve others, and be all that I created to be. Use all the gifts, God, that I have, put into you. God gives us a purpose. And for me, that's where it comes from. So whatever timeline we're in, I think we can serve God here. Now, you may choose to have an atheist view of all of this, or a view from a different religion of all of this, and you'll come to terms yourself with whatever you think the multiverse is. But for me as a Christian, this is where it comes down. I want to show you one last astronomical thing before wrapping up. So this is a spot in the sky. You can see there it is. So there's a bunch of stars here, and there's the moon. So if you're looking up and there's the moon, you see the little square there outlined in white. We're going to look at that spot in depth. It doesn't look like there's anything in it. It looks completely empty. But the Hubble Space Telescope looked at that spot over and over, took many, many photographs to see everything that they possibly could. And that little empty square, they found this. It's not empty at all. It's packed with thousands of galaxies. And we have every reason to suspect that every other spot on the sky is packed with it. It's like less than the size of your pinky fingernail at arm's length. is that thing there. So when you look at the night sky, this is the wallpaper of the universe. It's covered with these thousands upon thousands of galaxies. And there's so many different colors. They're so beautiful. There's red ones and yellow ones and blue ones and white ones, and there's blobby ones and round ones and spiral ones. Just gorgeous. Now, you can look at this, you can come to different conclusions. Some people look at this and go, ooh, universe is really big. Carl Sagan wrote, so Carl Sagan was an astronomer, great educator and communicator, but also an atheist. He said, we find we live on an insignificant planet of a humdrum star, lost in a galaxy, tucked away in some forgotten corner of the universe. Whew. Wow, that's depressing. I mean, lost? Forgotten? Forgotten by who exactly? This is not science. This is his view, which is fine to have, but it's a view that gets put on top of the scientific understanding of the vastness of our universe. The Bible actually has something to say about the vastness of the cosmos. In Psalm 103, it says, as high as the heavens are above the earth. Now, think back to ancient times. They pictured the heavens as this dome sky above a flat earth. As high as the heavens are above the earth, that is the full extent of the cosmos to them. And then it goes on, as far as the east is from the west, that's from one end of the universe to the other. It's talking here about the whole extent of the created order. If it's our universe, it's incredibly huge. If there's a multiverse, it's way vaster than that yet. And what God says here, as high as the heavens are above the earth, so great is God's love. I mean, you kind of expect it to be, as vast as all that is, well, so great is God's power, and so small and puny are humans, or something. Instead, God says, no, this is your visual aid for remembering how great my love is. And as far as the east is from the west, so far has he removed our transgressions from us. God invites us to picture his mercy and forgiveness, taking our sins and moving them to the ends of the universe, out into another end of the multiverse, if you like. It's incredible. This is the God that we serve. His defining feature isn't the incredible vastness of his love, enough to love any number of creatures that he's made, and enough to love us even when we keep sinning over and over. We have an amazing creator, and I hope you've enjoyed this little tour of the creation that he's made. Thank you very much.
Thank you, Dr. Haarsma, for that talk. We have about 25 minutes for questions. So I'm going to ask a question that was pre-submitted from the registration form to start, but get thinking. And Jim is over on that side of the room with a microphone. I'll be over on this side. We'll just go, we'll alternate back and forth. And raise your hand when you have a question, and one of us will come beside you. So, Dr. Haarsma, to start us off, sort of on the theme that you ended on, this was one of the pre-submitted questions, wondering how thinking about the multiverse or similar theories can cultivate spiritual goods that enchant our imaginations and aid us in our worship of God. So are there particular things, say the multiverse is true, that sort of would deepen our appreciation for God's creation?
Well, this is a huge example, this Bible verse that I talked about there. I think what science does is it expands our imagination. I think that was somewhere there in that question. Because I read this verse many times because I grew up in church, and so I knew that verse, and I just went right past it. As high as the heavens are above the earth, whatever. It wasn't until I was studying astronomy and actually studying the vastness of the universe, and then I read it again and went, oh my goodness. To realize, so what science does and what the natural world does is it illustrates some of these attributes of God, his incredible vastness, his power, the extravagance of his creation, the incredible beauty and variety in creation, the power and danger that you get in some aspects of creation. These all sort of illustrate God's attributes. He's the artist, and he's made all these different things. And it comes home to our senses. to our, you can feel it walking outside. You can see it with your eyes. You can hear it. And that enters into our spirits in a way that the printed word doesn't always.
Questions?
Hello, my name's Andrew.
Hello.
Thank you again for your talk. And my question revolves around, you mentioned Sean Carroll, and correct me if I'm wrong, he's an atheist, sort of outspokenly so. And one of the quote-unquote conflicts between faith and religion that critics of Christianity have often brought up is the inability to prove or inability to demonstrate God's existence. And yet, the multiverse theory or the multiverse theories are such that not only do we not have direct physical evidence of them, but in theory we can't.
Yeah.
And I'm curious why there's so much acceptance of a multiverse amongst the scientific community. And yeah.
Right. Yeah. That's a great question. When so many scientists are skeptical of God because he can't be proved, and yet they're willing to entertain the multiverse, which cannot be proved in principle even. Well, some of the models, the inflationary model, I showed you data of how it explains things in our universe. So there's some basis in data there. There are many scientists of atheists and all worldviews who are opposed to the multiverse theories for this reason. Others are entertaining them, and usually with caveats. I don't think they put them out there as like, this is for sure. It's more in the vein of, this is the best thing going. String theory is our best shot at understanding how gravity and quantum mechanics can work together, and we need to figure out how that works. So this also produces a multiverse. So I think it's more in that vein. I think I've seen a few who seem to be motivated by an anti-God stance to latch onto multiverse as an alternative to God. But it's more often, I feel like it's a physics motivation to it, or a this isn't science objection to it. But it can be a helpful conversation starter of like, so where is faith exactly in this? If you're talking with somebody who's keen on the multiverse and they're not a Christian, okay, well, to think about it is a really good conversation to have. So, thank you.
Thank you for a very nice talk. When I was learning quadratic equations, I was taught to, in physics, this was as an undergraduate, to distinguish the physically relevant solution from the one that wasn't. And what I'm wondering is, with the theories you've described, does a mathematical possibility in the theory necessarily represent a physical reality?
Yeah, no, not necessarily at all. So let me just put up that list of 4 of them again. So if the math works, does it mean it's really there in space? No, not at all. Not necessarily. It means it could be. So my own research has been much more observationally oriented, and we say, well, if we can't observe it, it's fine to have a theory, but it's not true until we see evidence for it. But then I remember back, was it Riemann, I believe, was the mathematician who first worked out curved space in the 1800s, and it was a purely hypothetical. Like nobody thought space could ever be curved. Worked out all the mathematics of it. And then Einstein comes along and says, oh yeah, actually that works around black holes. And then we discover it and measure it, and now we're like, yep, we can totally measure curved space. It exactly matches that. So things like that teach us to be a little cautious of writing it off, if we haven't found it yet, because we might. But it's not, yeah. Is it really science if you haven't measured it yet? Okay, over there, yeah.
So I'm curious, based on like all of your research and looking at these theories of the multiverse, do you have a tendency towards believing in one of them? Or like, and if you do, which one?
I would tend to the inflationary multiverse because I've been so impressed with how well it explains things in our universe. So I'm open to it. I'm open to there being an inflationary multiverse or not. And I don't know if we'll ever be able to tell. In fact, I don't think we ever can for sure. So I guess I'm willing to hold that one lightly. I don't feel a need to reject it. I don't feel a need to claim it. String theory, I'm waiting to see. Quantum multiverse, I just can't get my head around that one. So, yeah. Yeah.
All these various multiverses, do they all originate from the same Big Bang?
Oh, yeah, okay, that's interesting. So the string theory multiverse, each universe has its own Big Bang. In the inflationary multiverse, there's one Big Bang, and then from that spring all the other ones. In the many worlds, there's one Big Bang, and then it just keeps splitting from there on. In the infinite universe, there's one Big Bang. Now, in these books, these authors, I think Brian Greene in particular has tried to knit these together. Maybe they can be, you can merge the multiple theories of the multiverse so that they're all true. So that's another option. Yeah. Who's up next?
I'm going to insert one question here from actually the chat online. Do you know about the James Webb Telescope that was launched? Can you tell us a bit about that and what it was? Well, you can explain. It was launched in December of 2021. Sort of big deal in the
Still have a picture. Yes.
in the science world.
Come on. There we are. The James Webb Space Telescope. Yes. Oh. Woohoo. So I got up very early on Christmas morning and watched the rocket launch of the James Webb Space Telescope because this telescope has been in the works for like all of my professional career. And I've watched the endless delays and cost overruns and just so hoping it will work. And it's passed every milestone with glowing colors so far and just so excited about this. It is the largest mirrored telescope to go into space, and the mirror really is made of gold. It looks gold there because it's reflective at infrared wavelengths. The infrared wavelengths are going to allow it to observe the very early universe where things have all been redshifted into the infrared. And the launch went great, the unfolding went great. You can see on the back side of it that silvery stuff, that is the heat shield that is protecting it from the heat of the sun. And it's amazing, there's these 5 very thin layers that go from the intense heat radiation of the sun all the way to near absolute zero on the other side to protect the instruments. And then the mirror is made up of 18 different hexagons. And just it was a week or two ago, they published a picture, it had 18 dots on it. So it's aligned enough that each of those mirrors is getting signal. All of them survived the trip. Everything unfolded correctly, and now they're doing all of the alignment of it. So the first images will be in May or June. You can look forward to hearing more about the very early universe. Some of the first galaxies to form will be detected. That's a major goal. And the other huge goal is to detect other planets. So looking for other Earth-like planets out there that might have life.
Thanks for all this clarity you've given us this evening. A question about the laws of physics in the various multiverses. We have to assume they're the same? Is there any reason to assume they would be the same?
So in the, let's go back to that list. Sorry. No, this way, there we are. So in the inflationary multiverse, the one with all the bubbles, the parameters of physics, I've been saying laws of physics maybe a little loosely, but like the strength of the gravitational constant or the mass of the proton, things like that would be, are different in the different universes, and the string theory also. But there has to be something unifying in it. For this inflationary universe, for all these bubbles to bubble out, They have to come from some mother universe that has some properties, has something like laws of gravity and quantum mechanics in it for these universes to arise. And so there is something to those laws of physics. So how much are they the same? In many worlds and in just our universe, the laws of physics are the same everywhere. And that we can verify everywhere we have looked in our universe. It's amazing, the laws of physics, how light works, how atoms work, the kinds of atoms you see. You can observe this very distant galaxy. You see all the same physical processes you see nearby. It's really incredible.
Other questions?
Has there been like any time in your career that you have been significantly challenged, like through your faith, by what you've learned?
Somewhat challenged. I think in my upbringing, I picked up the idea that it's okay to not have answers to every question, which really helped me to distinguish between here's the core of our faith, where we're sure, and then there's secondary questions that we might not know the answer to, like how life arose, is evolution true or not? And that really helped me so that I was never in a total crisis of faith, because it wasn't all this absolute things all bundled together. I remember, I don't know, some point in late grad school or early postdoc, kind of getting bothered by this vastness of the universe and like, boy, it really is big, and maybe humans really are insignificant. And that's when I came across that Psalm 103 and I went like, whoa, wait a second. That's not the case. So that was certainly a moment for me. A huge key moment for me also was reading biblical scholars and reading what they had to say about Genesis, because I was holding that intention for a long time. Like, I love the Bible. I affirm that all of it is inspired by God. I don't want to use science to just pick and choose which I'm going to believe. But this stuff I'm reading in Genesis doesn't fit with what I'm learning in astronomy class. How does that go together? And then reading Old Testament scholars who explain the original context of the passage and what those words meant to the original audience. I got a deeper love of Scripture out of it and feel like I have a better understanding of what God is teaching us in those passages. So I'm very grateful to have come through that. A lot of people go through a much greater, deeper crisis of faith. We have a lot of stories of that on the BioLogos website. So, if you know somebody or you yourself are like wondering, I don't know how this all goes together, you are not alone. There's a lot of people who go through that, and there's a lot of good discussion that can be had. So.
In the Christian multiverse circles, I'm not sure how big those are, but are there conversations on how God interacts with or could interact with the various multiverse, like Jesus being born elsewhere besides a major, or multiple Christs dying for our sins, or how does that?
Oh boy, yeah, a little bit. I was looking back at some of that literature prepping for this talk, and yes, some people are concerned about that. I hear that kind of question much more in the context of life on other planets, which is a lot more tangible and is actually something that we might discover or could in principle discover. And the question of how God is relating to these different life forms. And there I often think through, well, God relates to humans. We know how God relates to us. We also know God cares about animals. Maybe life on other planets is more like how God relates to animals. They don't have sort of that ability to rebel against God. And then you have angels. We know in Scripture about angels. God created them. They rebelled, apparently some of them, and apparently didn't have a path of redemption because their fallen angels are in hell, but there's still some who aren't. So maybe we don't know how God is going to relate to every other kind of life out there. Maybe there's a similar plan of redemption, maybe not. The multiverse, where that comes in then, is if all of this is true and there's really other similar Earths out there and similar people, it seems like God would love them too and provide some way for them to also come to Him. What that looks like, I wouldn't want to say.
I want to go back to your point about Genesis and how challenging it was at one point. St. Augustine wrote his book on Genesis as very late in his career and waited until, I think, and he's the hinge figure that we look to for the hinge between the ancient world and the classical world. It was the waning of the classical world and the beginning of the dominance of Christianity. And somewhere in there, because he was in a period of time when Christians that were too sure of themselves were getting laughed at by classically trained Romans and such, he said something like, beware of imagining that you know everything, something to this effect, because otherwise people are going to have the ability to laugh at you. In other words, don't be afraid of new knowledge that will emerge later and keep on emerging. And the way that you study Genesis in that period was really as an account of natural history. So I feel very encouraged by Augustine's wisdom that we should not be afraid of the curiosity that has been implanted in us, and allow it to run its natural course and acquire knowledge and just feel humble in the face of enormity, not insignificant.
Oh, yeah. Oh, amen to all of that. Yeah, looking at the universe and seeing how hard it is to understand should make us humble. And if we can have an attitude of curiosity, just building on what you're saying, curiosity about the natural world, curiosity about what God is teaching in Scripture, a positive openness, a desire to learn. We don't have to defend God. Like sometimes we're like caught up in that, like, ooh, if this is wrong, then God, its reputation will be at stake. Well, God can take care of himself. We need to think more, how can we learn about what God is doing? There's real questions to be had about interpreting Genesis, but we can hold it a little more loosely too.
Dr. Haarsma, thank you. Just wanted to comment on the theological implications of particularly the quantum multiverse theory. This is something that really goes back in the history of thought to scholastic theologians, because they ask the question if God has knowledge of counterfactuals. And that is, if God has knowledge, and knowledge is defined as justified true belief, then God can only know that which is true. And God cannot have knowledge of that which is false. However, these scholastics ask the question, can God have knowledge of counterfactuals? That is, if Deb Haarsma had Cane's chicken for dinner and had heartburn, would she have delivered this talk tonight? And the answer might be no. And then God would know that. So really, the scholastic theologians were going down this road of there being a set of facts which are different from the facts which exist in our world. I think you were at Calvin, maybe with Alvin Plantinga. Were you ever there? Yeah. So he talked a lot about possible worlds, and so the question really would boil down to that the scholastic theologians in the Christian tradition rejected what's called middle knowledge, that is, that God has knowledge of these other worlds. Because if he did, then he would know something that wasn't true. It gets to be kind of a conundrum, and I had a theology professor who once said that God has to have knowledge of counterfactuals because he couldn't believe that God would condemn someone to hell after having rejected a spurious rendition of the gospel. And therefore, God must have knowledge of how a particular individual would respond if that person was presented with the gospel as it was truly represented in Christ. Huh. And so it comes down to kind of an interesting deal, because middle knowledge is what was rejected because the scholastic theologians just didn't want to go there. They said that would exclude the need for human decision, because a person would be saved not on the basis of their particular reaction, but in another universe, in another possible world, how they would have responded. Just just a little bit of interesting theological.
Yeah, that's a fascinating comment, and I think I don't know enough theology to comment too much on that, but I know sometimes theologians are talking about sort of matters of salvation, which might be a little different than matters of other sort of knowledge, but it seems to me we're made in God's image. We can certainly imagine counterfactuals, lies, all sorts of things. To say God couldn't know them, be aware of them, yeah, that's weird. Sorry, calling theology weird. Okay, over here.
Thank you so much for your talk tonight. And this kind of goes back to the quote cited at the beginning about where is God in the universe, and then also the enchantment question. And I think it's fun to speculate or just ask questions like within the bounds of orthodoxy or whatever that means for a particular person. But I want to sort of like in my mind's eye or my imagination, I often ask what is God's heaven? What is God's dimensionality? Where he dwells, and he of course chooses throughout the biblical history to dwell among his people in the temple, in the church, the new temple, in our hearts. He's everywhere, omnipresent and so forth, and yet seems to be local at the same time. And then we have like the Psalm 104 where, I imagine that God is sort of clothing himself with, the actual cosmos, where it says, you are clothed with splendor and majesty, covering yourself with light as with a garment, stretching out the heavens like a tent. So like as if he's somehow garbing himself, with the cosmos. And so like I guess the question is, in your personal piety, how do you imagine, God's presence, God's dwelling within this sort of understanding of the cosmos, and how does that, enchant your heart and imagination? Yeah.
Oh, that's a really interesting question. I like that. So I know some things some ways I don't imagine God. Some people who hear about the multidimensionality of space immediately want to go to say, oh, and then God lives in one of those other dimensions. And that's where Jesus went to when he was resurrected. And I don't like that because to me, I know those dimensions are all part of the created order. And so I picture God when I picture God in heaven, I picture that as separate from everything in the created order, all of the universe and the multiverse. It's somehow beyond and separate from that in some way. In my piety, I look out the window at whatever trees and sky I can see and let that sort of inspire me to think of, okay, those are things God created. And then that God of the cosmos is also right here with me is just stunning. Yeah, makes me want to fall on my knees. Yeah.
Thank you for your very interesting talk tonight. I'm a theologian, but I'm going to ask what I hope is a physics question related to the multiverse theories. Do any of these theories potentially allow us to posit a universe in which there is no entropy, a physical universe in which there is no entropy?
No, not really. So entropy is this tendency towards greater increasing disorder, which sounds like a really negative bad thing, except in physics, it's a process that actually leads towards all sorts of things that we care about. Like if we opened a bottle of perfume and gradually the smell filled the room, that's entropy. That's the diffusion process. Entropy is increasing. So it is fundamental to how stars work, to how life works. So it's hard for me to imagine a universe without entropy or in which entropy behaved differently. So probably not. It's probably in all of them, which is part of the fine-tuning thing itself, the sort of the greater fine-tuning, that even this multiverse needs to have some of these physical processes for anything like existence as we know it to be allowed.
And we're going to have our last question back here.
Hi. So you said that the inflationary multiverse was the one that you kind of find the most compelling, if there is indeed a multiverse. What does that theory explain about our universe?
Oh, yeah. I'm happy to explain that. Let's see here. Okay, let's go back. So remember the green and blue blobby stuff there. the way those blobs are arranged is something we can measure very precisely. So in this graph here, what's happening on the horizontal axis is it's getting at different sizes of the blobs. So you can see on the left, it's just very large scale changes in that green to blue spectrum. In the middle is moderate sized things, and on the right is very tiny things. And you can measure what's the prevalence of those. And you can see a big peak in the graph in the middle, and that means that it's the strongest, most typical size of these things is that medium size. And it's more unlikely to find very small features or the very large features. That's roughly what this is saying. And that curve there is the very precise prediction that is based on the properties of our universe and the inflationary model. So the inflationary model, it takes what were quantum fluctuations, just very smaller than microscopic fluctuations in the very early universe, and then undergoes this incredibly rapid inflation so that those very tiny particle level things are now expanded out to the size of larger than star clusters. And then that becomes the structures in our universe that can be measured in a graph like this. And so this is a graph showing that curve in even more detail with the data on it, and it matches this inflationary model. So it's explaining how the structures arose, how those blobs in the microwave background, the green and blue things, how those came to have the shape and intensity that they do, the typical size, and then those in turn became all of the structures we see today, if all of the galaxies that we see. So we wouldn't, it takes that inflationary model to explain where the structure comes from. Otherwise, the universe would be perfectly uniform, and all you would have is just diffuse gas everywhere. You have to have some regions where it's clumpier and some regions where it's less, and in the clumpier regions, the material can collapse under gravity and form into structures.
On that mind-blowing note, let's give Dr. Haarsma another round of applause.
Thank you all. Thank you.